All right, let's go ahead and get started. Here's our agenda. We don't really, normal week, nothing too special. So tomorrow is the second droplet deadline for the semester. We do have new outcomes coming onto our Friday assessment this week, F8. So that's our last fundamental outcome, very exciting, and G20 to G22. But again, if you're not ready for it, you can choose to wait until next week to start them if you want to work on old outcomes first or something like that. So you can kind of customize the schedule a little bit to yourself. But other than that, it's normal. So we'll start with our quiz and as usual, do the individual version first and use your raise hand feature when you're done. So you guys can go ahead and get started. Oops, I should be recording. So we're just going to go through a couple of the problems from the Jamboard. So first of all, so this is a question about completing the square. So completing the square is pretty cool. It's kind of a fun technique and that ties together different things that we've been doing. So like sort of reverse factoring and solving equations and stuff like this. It's also where you get the quadratic formula. So if you just take a general like ax squared, oops, ax squared plus bx plus c equals 0, and you go through the completing the square process, complete the square, you'll get the quadratic formula if you do it properly. So these two things are actually very, it's the same thing, right? It's just the quadratic formula has like already like rearranged everything on the other side for you to solve for x. That said, so I'm going to go through an example with completing the square. It's nice practice. It's nice to see how those things tie together. But in practice on our Friday assessments, you can just always use the quadratic formula. So you don't like have to learn how to do the completing the square. It's a nice thing to see how it works, but we don't have to. So I think for the homework you have to though. So it's good to see it. So we're going to take this thing and this 3x squared minus 2x minus 1 equals 0. The first step is we want to get 1 in front of the x. So we're solving for x. So we're going to divide both sides by the 3. Divide both sides by 3. Multiply by 1/3. Obviously, it's not doing anything to the 0 side, but we get x squared minus 2/3 x minus 1/3 equals 0. So in this case, we're introducing fractions, which probably doesn't make anyone comfortable, but that's how we do it. And then the next step, what we're going to do, if you want, you can go off to the side, is to take this b value and you're going to divide by 2 and then square it. So we're going to take the b value, divide by 2 or multiply by 1/2. So we get minus, in this case, the 2 cancels. So we just get minus 1/3. And then we're going to square it. Equals 1/9. And then we're going to add that 1/9 to both sides. Oh, before we do that, actually, I'm going to, unlike how we handle things when we're factoring, we always want to get 0 on one side. In this strategy, we're going to take that constant value, the one that doesn't have any x's, and add it to the other side. So we have x squared minus 2/3 x equals 1/3. And now we're going to add 1/9 to both sides. So we're not changing anything because you're changing it, but you're changing both sides of the equation by the same amount. So we'll add 1/9 to both sides. X squared minus 2/3 x plus 1/9 equals 1/3 plus 1/9. And the reason why we're doing this sort of crazy thing, so maybe I'll label this over here. So this is the b value times 1/2. That's what this is. And then this is this thing squared. And then we add it to both sides. And then the reason why we're doing it is if we've done all of that stuff properly, and I don't remember that, I always have to like relearn the completing the square formula. But if we've done that, both of those things, all of this stuff properly, then we should be able to write this thing as a square. And so this is why they're something squared, a binomial squared. This is why they're calling it completing the square, is you're taking the side, you're adding the right thing to it, which we figure out using this, to be able to rewrite this as something squared. And in particular, the thing that you're getting squared is going to be x plus this value that we found over here. So we should get on the right side, x, in this case it's a negative and that matters, so we have to keep track of that, x minus 1/3 squared equals, and over here 1/3 is 3/9, so this is 3 plus 1 is 4/9. So here we're taking this value minus 1/3. That's the same thing that we're using over here, minus 1/3. If we've done it all properly, but you can check, right? You can FOIL this back out, x minus 1/3, and you'll get minus 1/3 x minus another 1/3 x, which gives you the minus 2/3 x, and minus 1/3 times minus 1/3, it gives you the plus 1/9. So you can FOIL it back out to check that you have the right thing. And then once we have it in this form, you can take the square root of both sides. So we're going to now take the square root of both sides, and we get x minus 1/3 equals plus or minus the square root of this side, and the square root of 4 is 2, and the square root of 9 is 3. So in this case, we even have nice perfect squares. And so we get x equals 1/3 plus or minus 2/3. And remember, this is actually two solutions. This is x equals 1/3 plus 2/3, which is 3/3 or 1. And x equals 1/3 minus 2/3, which is minus 1/3. So we get these two answers. And if we've done this properly and you do the quadratic formula, you should get the same answer, right? So that's a nice way to check as well. So that's how completing the square works. It's basically doing the same thing as the quadratic formula, but sort of doing out the steps of it. And let me know if you have questions. I know somebody had asked about completing the square on our homework file. Okay, and then I also wanted to talk about inequalities. So I'm seeing some things on the Jamboard that are looking okay and some things not so okay. And sometimes there are strategies that work for simpler inequalities that are not going to work in more complicated situations that we're going to have to deal with also. So I'm going to go through a couple of examples the way I do it to show you what I'm doing. So this is from actually the Monday Jamboard, just because these are the ones I grabbed. So we have this first one is just a polynomial, so it's a little simpler than we get when we get rational things, when we have things in the denominator. But the first step, well, the sort of 0th step is to get 0 on one side. Step 0, get 0 on one side, which we're already have done in this case, but sometimes we have to do that. The second step is to find the zeros. So in other words, we're going to, i.e., solve the equality, the equation, instead before we solve the inequality. So we really want to pay attention to the fact that we're solving an inequality. We're trying to find all the x values that we can plug into the left side that make this thing negative. Maybe I will even write this down. So when we're trying to solving this means finding all the x values that give, in this case, it's a negative number because we want less than 0, a negative number, something less than 0, when we plug it into the left side. That's what we're trying to do when we're solving the inequality. And in order to solve it, the first step is to solve the corresponding equation, because the places where it's equal to 0 are places where it can switch from being positive to negative or negative to positive. So we're going to solve the equation x squared minus x cubed minus x squared minus 20x is equal to 0. And in order to do this, well, you might have to use the quadratic formula, but hopefully we can just factor it. So we'll pull out a common factor of x. We have x times x squared minus x minus 20 equals 0. We have x times x minus 5, x plus 4 equals 0. So this gives us 3 zeros. It's important that we don't lose this x equals 0 factor. We have x equals 5, and this one gives us x equals minus 4. Okay, so you know, if you want, you can try to keep track. Like, oh, if I want to get something that's less than 0 and I'm multiplying these numbers, I want something negative. I could have one thing be negative and the other two are positive, or this one's negative and the other two are positive, right? Or maybe all three of them are negative, right? There are a lot of things to keep track of. So it's best to, especially as they get more complicated, to do what we call sign analysis. So we set up this chart where we make a number line and we mark off the different breakpoints. So here we have -4 is the smallest, and then we have 0, and then we have 5. And so now we've broken the number line into 4 different regions. So we have this region, which is -infinity to -4. We have this region, -4 to 0. This region from 0 to 5. And this region from 5 to infinity. And we're trying to decide for each of these regions, when I plug in x values, is this thing going to give me a negative number or is it going to give me a positive number? And so we're just going to do test values from those regions. So you can test maybe x equals -10. And for the next region, I can test maybe x equals -1. And then the next region, I can test maybe x equals +1. And the next region, I can test something else, maybe x equals 10. And you can, if you want, plug your test point into the original thing, or at least after we've gotten 0 on one side, right? The thing that we want to test, whether it's negative. But if I try to compute this number by plugging these things in, I'm probably going to make mistakes. And so it's easier to test on the factored version, where you can test something times something times something else, because we don't care what the actual numerical value is. We just want to know, is it positive or negative? So I'm going to test against test x times x minus 5 times x plus 4 to see if it's positive or negative. And so I'm just going to plug it in. So if I plug in -10 to x, I get in -10. -10 minus 5 is -15. -10 plus 4 is -6. So I don't care what this number is. I don't actually have to multiply it out. What I need to know is that a negative times a negative times a negative gives me a negative number. If I plug in -1, I'm going to get -1. -1 minus 5 is also a negative number. -1 plus 4 is +3, so it's a positive number. So negative times negative is positive. And that means any x value that I plug in between -4 and 0 into this thing is also going to give me a positive value, because there was nowhere else for it to switch. And the same thing, I can test x equals 1. So I have 1 times -4 times 5. So this is going to give me a negative value. And then I can plug in x equals 10 times 5 times 14. Again, I don't care what it is, just that it's positive. And in this case, because we want less than 0, we want the negative regions. So I want this region and this region, which is this and this. So our answer is the x values in the intervals -infinity up to -4. So that means anything less than -4, and anything that's in between 0 and 5. So this is how we go out solving it. We can figure out where is it positive or negative. And you can check, right? If I plug in, I mean, already we checked x equals 0. If you plug in -10 or something, we're good. Oh, we did that already. -5, you're still going to get a negative value. The other one that was on this same slide was a rational inequality. So in this case, we have to be careful because the numbers that are 0, the numbers in the denominator can also change whether your overall function is positive or negative. So we're going to take the same kind of approach. So our first step is to get 0 on one side. And with a rational equation, you also have to write it as one fraction. So this is already done. Step 0, part B, write as one fraction. In this case, again, that's already done, but sometimes you have to add the fractions together or subtract them. And then step 1, now we have 2 parts. We need to find the zeros of the numerator and the denominator. So in the numerator, we have just x minus 1 equals 0. So x equals 0, that's great. In the denominator, we have x squared minus 2x minus 8 equals 0. We have to factor this. X minus 4 times x plus 2, I think. So we have x equals 4, and we have x equals minus 2. So now when we set up our number line, we have to use all 3 of these things as breakpoints. So step 2, our sign analysis.
Isn't that x equals 1?
I do it wrong. Yes, thank you. This is x equals 1, not x equals 0. Otherwise, my whole thing would have been messed up. Okay, so we set up our sign analysis. So we have minus 2 as a breakpoint. We have 1 as a breakpoint. We have 4 as a breakpoint. So again, in this case, we happen to have 4 different regions. So we have the region from minus infinity to minus 2. We have the region from minus 2 to 1, from 1 to 4, and from 4 to positive infinity. We can test different values in here, like x equals minus 10. Maybe test x equals 0 is a nice, easy one to do. Test maybe x equals 2, and maybe x equals positive 10. Again, I'm going to use the factored version of this. So the x minus 1 on the top is fine, but I'm going to use x minus 4 times x plus 2. Test x minus 1 divided by x minus 4 times x plus 2. And I'm not even going to track what the numbers are. I'm just going to track whether the numerator and the denominator are positive or negative. So when I plug in x equals minus 10, on the top, I'm going to get a negative number. On the bottom, I get minus 10 minus 4 is going to give me a negative number. Minus 10 plus 2 is also a negative number. So 3 negatives, we get a negative number over here. If we plug in x equals 0, we get a negative number in the top. 0 minus 4 is also negative. 0 plus 2 is positive. So 2 negatives, we get a positive number. If I plug in x equals 2, 2 minus 1, this time the numerator is positive. 2 minus 4 is still negative. 2 plus 2 is also positive. So 1 negative gives us a negative number. And then plugging in 10, we get positive on the top and positive times positive on the bottom. So overall, we get a positive number. And then we go back, and in our inequality, we want this thing to be bigger than 0. So in this case, we want the positive regions, which is minus 2 to 1 and 4 to infinity. So our answer is minus 2 to 1 union 4 to infinity. So that's how we would do it in this case, where we have what we call a strict inequality, strictly bigger than 0. If we had the exact same problem, but we had greater than or equal to, we'd get a slightly different answer. So if we had instead the same problem, x minus 1 over x squared minus 2x minus 8, but we wanted greater than or equal to 0, then we would have to include the numbers that make this thing equal to 0. And remember, you can only get a 0 when you have a fraction. It can only be equal to 0 when the numerator is equal to 0. The denominator equals 0 is undefined. You can't divide by 0. So here we would do, if we were starting from the beginning, we would do all the same work, except we just did it. So we can just, in this case, write down our answer. It's going to look almost exactly the same. We're going to go everything between minus 2 and 1 is going to give us a positive number, but 1 is also going to give us actually equal to 0, right? Because we have 0 in the numerator and not in the denominator. So we use a square bracket to include 1, but 4 also gives us a 0 in the denominator. So we use parentheses to infinity. So we have to pay attention to whether they want positive or negative, and then whether they're allowing us to include the equal to 0 part. Okay, so that's all we have for today. We have study time hours tomorrow, so come in if you're having trouble. You're going to do some practice with these. The inequalities are definitely harder than equations, right? We have to do the equations part of it, but then we'll have our Friday assessment with a few new outcomes this week as well. Okay, that's it for today.